Hello everyone. Welcome to today's webinar, Deploying VMware Virtual SAN in Minutes with Big Cloud Fabric. My name is Prashant Gandhi. I'm responsible for products and strategy at Big Switch, and I'll be your host for today's webinar. We are delighted to have John Nicholson join us from VMware. He is Senior Technical Marketing Manager at VMware. Welcome, John.
Thanks for being here.
Also, we are joined by Arkady Shapiro from Big Switch Networks. He is Principal Technical Marketing Engineer at Big Switch. Welcome, Arkady.
Hello, everyone. Great to be here.
As we go through the presentation, feel free to ask questions using the Q&A box on your webinar dashboard. If you're watching this video in a rebroadcast or a recording, or you have questions on a particular upcoming webinar topic that you would like our panelists to address, just go to bigswitch.com/webinars and submit a question using the link provided. We've also provided you with handouts for today's session. You can download them from the Handouts tab on your dashboard. Our first speaker today is John Nicholson. John, take it away.
Hey, thanks for the great intro. Again, my name is John Nicholson. I'm a Senior Technical Marketing Manager in Storage and Availability at VMware. I'm primarily focused on vSAN as the core technologist. Let's get started. So a quick refresher in case you haven't seen what virtual SAN is. Let's talk about what it is. So virtual SAN uses generic x86 hardware. It uses traditional servers, that you already have in your VMware environment. It's integrated into the hypervisor, which means if you have vSphere 5.5 update 1 or newer, you already have virtual SAN. You may just not have licensed or configured it yet. Next up, we take local storage resources. We don't need an external expensive disk array. We're going to leverage local disks and these servers, and then we're going to combine them together to produce a single shared data store. And what the single shared data store will do is provide resiliency. It provides all the great VMware features you're used to needing for shared storage, things like high availability, DRS, vMotion, and fault tolerance are all supported. Now we've got two primary deployment topologies for virtual SAN. We've got hybrid, which is what we started with in 5.5 update 1, and it's great. It gets about 40,000 in operations per second. And what the hybrid does, how it works, is you've got an SSD tier or a flash tier. It could be NVMe, PCI Express, different kinds of flash. And this is split up into 70% of it being a read cache and 30% being a write. So all writes go immediately to that flash. They're acknowledged very quickly, and the hot data will live within that read cache on the flash device. Now, as data gets cold, it's destaged down to a lower cost magnetic tier made of SAS or SATA type devices. Now, this is great, but we introduced all flash in 6.0, and what's great about all flash is all flash uses two different types of flash. We still have a two-tier architecture, but we use a little bit higher cost, high endurance, a small write buffer. It's 100% write buffer at this point, in front of a lower cost, often known as sometimes read optimized capacity-based flash devices. What's great about all flash is you get 100,000, 150,000 in some cases, operations per host, and you get 100% consistent sub-millisecond latency. And what we're really seeing as time goes on, customers are choosing all flash as their default deployment topology because it enables additional features like deduplication, compression, RAID 5, and so forth. So just wanted to show that virtual SAN is really easy to set up. On the screen, as you can see, it's just a couple checkboxes. We decide how we're going to claim the local disks and storage devices. We decide whether we're going to turn on deduplication compression. It's a single checkbox, no giant star chart of delays or feature combinations. And then we decide if we're deploying something like a stretch cluster or if it's a two-node, commonly used for remote office, branch office, and away we go. So virtual SAN networking. Virtual SAN is obviously, as a distributed storage system, is very dependent upon its networking. So I had a couple things I wanted to discuss about this. First off, people often ask, which type of virtual switch should I use? We've got obviously the standard switch that you all know and love, but also we've got the distributed switch. And previously, if you weren't using the distributed switch because of licensing reasons, I want to point out that virtual SAN includes the distributed switch. And the distributed switch has got some great functionality, things like LDP, LACP. It's got a bunch of different hashing algorithms beyond the basic IP hash. It also has things like network I/O control. And while standard is supported, I really encourage you to use distributed switch, especially because of network I/O control. And to talk a little bit about what network I/O control is, skipped a slide there. So network I/O control allows prioritization of traffic. So previously in your traditional fiber channel storage environment, you had a separate network entirely for storage because it was so important you didn't want any conflict with traffic. What network I/O control allows you to do is host-based traffic shaping. And it allows you to have, by default, there's some shares that are applied and they're pretty good. And these shares basically set priority weights. So that way the virtual SAN traffic, while you could deploy its own dedicated switching, you don't have to. You can merge virtual SAN and vMotion and management and other traffic keys together. Now, we'll point out as a best practice, I would not go to set any hard reservations or limits. This is where people can kind of get in trouble. Rather than just check the box and walk away, limits obviously can have some performance impacts, and also hard reservations actually, while they are yielded between the different types of management traffic classes, like virtual SAN, if it's not using all of its reservation would yield to vMotion, they'll never yield to virtual machines. It's not always commonly understood. So you kind of have to be careful there. In terms of link aggregation, we also support LACP, so we will use multiple links, and depending on your hash that you're setting for that, your mileage may vary in terms of how much throughput advantage you'll get from that. Now we have two different deployment topologies from a network standpoint. We've got what's known as layer 2, and this is where traffic is kept entirely within one subnet for the entire cluster. We also have a routed layer 3 topology, and it should be noted that virtual SAN uses multicast. And so if you're going to use a layer 3 topology with normal traditional switching, and my co-host here will get to more in a second about some of the advantages of big switch, layer 3 can actually be a lot more complicated and a lot more time consuming to properly set up, and there's more to troubleshoot. Layer 2 is typically used in simpler topologies. And in the majority of deployments. Now it should be noted that virtual SAN can do things like rack awareness, and it can do site awareness, and it can stretch between sites, so you can make sure your data is mirrored between different cabinets for availability. And in that case, it's not uncommon for people to say, hey, we don't want a broadcast domain to stretch between cabinets or things like that, you know, if you're looking at some type of, you know, OSPF model. So that's where a lot of people in some of the larger, more complicated environments may be considering layer 3. I do want to talk quickly about link speeds. So from a link speed in your environment, virtual SAN loves throughput. Because the data is distributed across the nodes and the data doesn't follow the nodes around, there's no data locality, as that actually causes other performance considerations. You have to consider the link speed. Now if you've got a virtual SAN cluster that's entirely within one cabinet, and you're just going to your top of rich or top of rack or switch stack, you're going to have full port-to-port throughput. But as I mentioned earlier, in your virtual SAN, you may decide to split your virtual SAN up between sites, maybe between pods, between floors, between cabinets. And because of this, you're probably going to involve more than one switch stack. And at this point, you're looking at having multiple switches. So some things to watch out for is if you're still running a traditional 3-tier network design with, you know, aggregation, core, and access layer, that's a lot of spanning tree, and you've got a lot of ports that aren't going to be active. So be aware of that, and that's why we really push for people to look at something like a leaf spine that's got a lot more throughput options. The other thing also is if you're using blades, while not a common choice for vSAN, people often use the built-in blade switches. And historically, those have often had or heavily oversubscribed links. So, and really where this becomes an issue is if you've got a rebuild, you lose a host that maybe had 20 terabytes of data. Now that data is distributed across all the nodes, and it will rebuild across all the nodes. So as the cluster becomes larger, it can rebuild faster, but it can only do that if there's lots of throughput between the hosts. Now the other thing again to watch out for is any type of line cards extensions or types of devices that lack east-west capability. So just because a device has a lot of ports, if it can't talk between those ports, that's going to cause problems as you try to scale up vSAN and grow it, because you're not going to get the benefits of increased speeds and access and increased rebuild speeds and things like that. Virtual SAN, if you have proper throughput availability, actually becomes more resilient and much more performant as it scales. But again, we've got to make sure we have that. And I do want to note that we do support equal cost multipath fabrics, which again we'll get to in a little bit. But these are supported, and these are a great way to abstract things like multicast and deliver, you know, the full fault isolation of a layer 3 type deployment without necessarily having to go too deep into that. Now, if you want to troubleshoot, we have some things that are host-based. And again, this doesn't have full visibility into the switch fabric and things like that. But what this does is this allows you to look on the host and look for common misconfigurations. So starting with 6.2, this became a native functionality. As you can see here, there's a health tab. There's dozens of checks. And this will look for common failures, common misconfigurations, looking for things like maybe the MTUs not set correctly. And the idea is this will help you communicate with your networking team saying, hey, this is what I'm seeing from the host side in vSAN that needs to be fixed or taken care of. We also have some basic performance tests, and there are some limitations to these tests, but if you want to test multicast performance, again, vSAN uses multicast from, and let me clarify here, from metadata, which is technically less than 1% of the traffic in most environments, but it's still very critical that multicast is performant. And it also uses a significant amount of unicast just for the actual data traffic. So this allows you to test between the nodes. Again, this is a host view only. This doesn't have full visibility into what's going on, particularly as you have larger fabrics. You're going to want some supplemental viewpoints from the networking side. But what I will note is when you run this test, a lot of people freak out because they'll see that they have one host missing. I just want to note that this test is sourced from one host. It's at random chosen. So if you have a host missing, that's the one that the test will run from, so just be aware of that. And this is great for validating the initial environment, making sure that everything from a performance standpoint, you don't have any outliers. If you look at the environment, you see that all but one of the hosts are performing correctly, then it's time to go take a look at what's going on with that host. Maybe it's got a bad cable or something like that. And that's where this helps identify before you go into production and know that your vSAN's ready to perform properly from a storage and networking basis. Now I'd like to hand this over to my co-host here to talk about the amazing opportunities that Big Switch has to provide a true end-to-end visibility.
Excellent. Thank you, John. So my name is Arkady Shapiro, Principal Technical Marketing Engineer at Big Switch. So John talked a lot about what makes vSAN unique in the hyper-convergence marketplace, and also what are some of the physical networking considerations when deploying and operating vSAN. Now let's take a look at how Big Cloud Fabric makes deploying and operating vSAN worry-free, and how we really end up deploying vSAN in minutes with Big Cloud Fabric. So before we dive in, let's have a quick overview of Big Cloud Fabric. BCF is a leaf-spine data center fabric powered by SDN controller and open networking switches running SwitchLite's operating system. Controller is a single point of integration with orchestration systems such as VMware vSphere, and really our proven integration with vSphere is what allows us to deploy vSAN in minutes. Now, there are a couple of things that I want to mention about this fabric that are important for vSAN. First of all, the fabric does equal cost multipathing for layer 2 or layer 3. And so regardless of whether you choose to do layer 2 for vSAN or you choose to do layer 3, right, the different topologies that John mentioned, we are completely agnostic to that, and we'll make the deployment very simple, which is a very important thing. And the second part is that this is a high-performance fabric. Right? There is no such thing as taking traffic up to some aggregation layer like we did in traditional box-by-box networking designs. Here you have finally fabric. You have local switching at the top of rack switch, which is a modern high-performance switch based on a latest silicon from Broadcom. So none of those issues that John mentioned before that sometimes appear with traditional networks are happening here with the Big Cloud Fabric. Right? And as I mentioned already, this fabric has a single point of integration with VMware, which allows us to do automation and get great visibility for all of the VMware products, but here we're talking about vSAN. Okay. Now, before we dive into specific features that make vSAN deployment with Big Cloud Fabric so worry-free, it's important to mention the architectural synergy, right? Why are two products kind of meant to be together, why they're better together. And if you look at this, you'll understand why. Now, the architecture principle for Big Cloud Fabric is really one logical switch. Right? So we use the controller. The controller manages the fabric with the open networking switches, and it looks to a user as one logical switch. A couple of features that are provided by this is network hardware choice. Right? We have a choice of bright box and white box type of switches, right? Things that come in from Dell or from Acton. We have zero box-by-box configuration because just as with a modular switch, you don't go into configure individual line cards. Right? You configure it from a single console. And finally, the controller, the SDN controller, gives us the end-to-end visibility. Now, something similar can be said about virtual SAN. Virtual SAN presents one logical data store for the VM admin. It's integrated with a hypervisor. Just like the big cloud fabric, virtual SAN provides you a choice for disks as well as multiple vSAN-ready nodes if you want to deploy vSAN. And you have per VM storage policies that are globally visible, but the storage policies can be configured for a specific VM, right? And they really control what disks and what data store VM is placed in. Okay. Now, let's dive into the specific features that are important for the integration with vSAN, right? And really, we have the integration with vSphere, and these features are applicable for vSAN. First of all, fabric automation. When we talk about fabric automation, what are some of the things that we do? When you try to attach a vSAN node to the fabric, typically on the network, you have to do a lot of configuration. You would do things like multi-chassis lag, you would add that link to the fabric and things like that. In our fabric, none of those things are happening because essentially we do that configuration automatically. We talk to the vCenter, we discover what are the teaming modes that are configured. So John talked about the various teaming modes that can happen. You can configure active-active or active standby. Regardless of what is configured on the vCenter, we pick that configuration up and we appropriately configure the fabric. So absolutely worry-free from kind of a day zero deployment. Second thing is the vSAN network creation for the VM kernel communication. Now vSAN uses a specific VM kernel for the vSAN communication. And we create that network automatically. Based on the port group configuration on the virtual switch, the appropriate transport network gets created on the fabric. And finally, the multicast deployment. Now, vSAN requires multicast today. And oftentimes, even if you're a CCIE expert, even if you're an expert in multicast, typically, this is not something that you kind of want to have to worry about, right? You want things to be much simpler in terms of deploying and troubleshooting. Now, deploying multicast in the cloud fabric, whether it's L2 or L3, it's as easy as one click, right, which is a very powerful thing. And the reason that is done is because of the architecture of the cloud fabric, because we have a single controller that manages this entire fabric of open networking switches running the SwitchLite OS. Now, automation is great, but what about troubleshooting and monitoring? We provide various tools for troubleshooting, both for the network admins and, very importantly, for the VM admins. Now, for the network admins, what we have is VM Analytics. There's an analytics engine on the big cloud fabric that provides you a historical view of all the events that are happening on the vSphere site. And so the network admin can really see and troubleshoot events over time. And the other thing that we provide is cluster troubleshooting for unicast and multicast using a feature we call test path. Now, this is provided for both the network admins on the big cloud fabric console, the GUI or the CLI, or using the REST API, and also for the VM admin through our plugin for the vSphere web client. It's a very important thing. And since John talked about the tests that the vSAN provides, right, the various health checks and tests for networking health, this is something that you can use to complement those tests, right, because this is something that tells you actually where the problem may lie, right, where some of the tests that John mentioned on the networking side, they may help you pinpoint that there is a problem. We will go one step further and tell you that, hey, the problem might be on this particular switch. The reason that you have no communication is because there's a policy on the physical network that's preventing this communication. And so really trying to help you narrow down the problem further, trying to reduce your troubleshooting time from days or hours to minutes. And very importantly, that this view, this troubleshooting view, is provided for both VM admins and network admins. So both of them see the same thing. Both of them have the exact same view of the infrastructure. Okay. Now, let's see how those features apply. The deployment with BCF for virtual SAN is really as easy as 1, 2, 3. First of all, what we do is we enable the vCenter integration by registering with vCenter, and as soon as that's enabled, we have that automatic host attachment to the fabric. Right? The lag and mlag configuration that you typically have to do manually gets created automatically without any user intervention. Now, second, we enable multicast inside the tenant that we use for that specific vCenter. And as I said, enabling the multicast is really one click, whether you're deciding to use it for layer 2 or layer 3. And finally, on the vCenter, we deploy vSAN on the cluster. As soon as we deploy vSAN, we enable vSAN on the cluster, and we create the VM kernels. And typically, we would assign VM kernels to a particular port group on the virtual switch. And as soon as we do that, the virtual SAN transport network gets created, and the endpoints get provisioned on the fabric. And so really, from those actions on the vCenter side that you use to configure vSAN, the network is automatically provisioned. So for a vSAN admin, it really becomes worry-free, and from an overall deployment, it's really as easy as 1, 2, 3. Okay. Now, this was the initial configuration, and there's a couple more things that typically folks want to do to make a robust vSAN deployment. So let's take a look at a more complete config and kind of compare this in perspective with traditional networking. So if you look at a traditional box-by-box network, here's all the types of configuration that you would have to put in on every single switch. So for example, we talked about configuring MLAGs, configuring VLANs, configuring VLAN memberships. Multicast typically requires, depending on whether the switch is in layer 2 or layer 3 mode, configuring IGMP snooping or PIM. Now with PIM, there's a couple of things like rendezvous points. Maybe you're doing PIM redundancy with AutoRP or MSDP and things like that. And finally, routing protocol, and you might want to do QoS as well, right? Because you want to have something on the network to match that network I/O control that John talked about earlier. Now, contrast that with the big cloud fabric. Really, all of those things that I mentioned on the right side are configured only once. Enabling the vCenter integration can be done through CLI for the GUI, which gives us all the automation that we have. Enabling multicast, as I said, one click for the entire tenant that's used for vSAN. Enabling QoS, we'll look at that in the next slide. Really, a couple of clicks to make sure that the network provides a minimum bandwidth guarantee for vSAN traffic. And finally, configuring the layer 3 gateway. If you want to use layer 3 for vSAN, if you want to have multiple networks for vSAN, and typically what we see with Big Cloud Fabric and our customers that are using vSAN on top of Big Cloud Fabric is they would use that in a case where they have multiple vSAN clusters. Right? So they have multiple vSAN clusters, they configure different port groups on the vSphere side, and that gets mapped to different networks on the Big Cloud Fabric side. And then if you need routing between these two networks, then you might configure layer 3. So configuring layer 3 is easy. It's really a couple of clicks or a couple of CLI commands on the CLI. And the reason that we do that is because we have a distributed gateway. And so you don't have to configure it multiple times on different switches. As I said, we configure it once on the controller, and the gateway is provisioned across the leaf layer. Okay. So I mentioned QoS earlier, and what about QoS? Now, we mentioned network I/O control. John talked about that quite extensively, and network I/O control is the QoS on the virtual side. Now, obviously, if you've gone through that work to make sure that you have the network I/O control, you want to make sure that you have some basic protection on the network side, and especially when the network is shared between vSAN and other workloads. Now, we make that protection very easy. Essentially, what you do is you pick up a segment that's used for vSAN, you assign it to a QoS traffic class, and you provision a minimum bandwidth guarantee for that traffic class. And so now your entire vSAN transport is protected, and you have the bandwidth guarantee for the entire fabric. Right? Compare that to having to configure QoS and having to configure minimum bandwidth guarantees and policing on every single box that you may have. And so huge difference here and huge simplification. Okay. Now, we talked a lot about features that are important for network admins, right, in terms of provisioning vSAN on top of the network. But a lot of times I get a question, well, you know, I'm a VM admin or I'm a vSAN admin, and this is all great, but I don't really care. I just want the network to work. And, you know, maybe I'm a little bit selfish and I don't care about how much work my network admin has to put in on a typical box-by-box network. But that's fine. And the question is, what do we provide for the VM admin? Now, for the VM admin, we provide a couple of things. First of all, through our vSphere web client, we have a couple of capabilities in terms of monitoring and troubleshooting. First of all, the network visibility, where we can see the exact physical network that's attached to our virtual machines and to our VM kernels. So here on the left-hand side, you will see the complete mapping between port groups to physical adapters on the ESXi host to the actual switches on the fabric. Right? So you'll see the two leaf switches that are coming from the big cloud fabric and the physical ports on the big cloud fabric. Now, the other thing that I mentioned earlier is this capability of fabric test paths. And the test path, same test path that we have on the big cloud fabric, we have ported that over to the web client, to the vSphere web client plugin, which really allows the vSAN admin to do VM to VM or vSAN node to vSAN node troubleshooting. Right? So, for example, troubleshooting path between the two VM kernels, seeing that path hop by hop through the network, and also knowing where the problem may be. We've actually done quite a bit of work in terms of adjusting the errors that we present to the user, because sometimes the errors that we present on the network side, they may not be as intuitive or as understandable to the vSAN admin. So we've done quite a bit of work to make sure that the errors that we present to the vSAN admin actually mean something to the vSAN admin, and the vSAN admin has the right tools to go and talk to their network team and essentially help pinpoint the problem faster. Now, the other thing that we provide is a content pack for VVLS log on site. So those of you who are familiar with log on site, it's a great tool that provides vendors such as Big Switch to plug into that tool and have events correlated using dashboards. So we have a content pack, various different dashboards, and the ability to configure alerts and customized alerts. And also in conjunction with the content pack for VMware VSAN, we're able to kind of provide one view for the entire infrastructure in terms of logging. That's a really powerful capability, and the important thing is that the virtual content pack and the Cloud Fabric content pack are working together to give you complete visibility of the entire infrastructure. Now, one more thing. We see customers deploying various VMware products. Sometimes they may start with vSphere and they're looking at vSAN. They may start with one version of vSAN, and later on there might be a new version of vSAN that they want to try, and they may want to share a production environment of virtual SAN and also a test environment as they're trying maybe a new version, or maybe they're trying a different VMware product such as an SX. And for this, virtual pods capability within the big cloud fabric really comes to help, right? Where you can share one physical fabric across multiple different orchestration systems, multiple different deployments, either, as I said, different products or different versions of the same product. Right? So combining dev test together with production, really we have customers that are sharing the same switch, and one port may be used for a test environment, another port may be used for a production environment, completely secure and isolated in terms of data plane, control plane, and administration plane, where we're really, in terms of the automation, we synchronize the configuration only with the tenant that has that configuration change, right? We would not touch any other tenants. It's a really powerful capability that the big cloud fabric provides, and it really helps particularly VMware customers onboard new VMware products and new versions of VMware products. Now, in summary, we talked about the worry-free networking for virtual SAN. Let's take a look at a couple of things that John mentioned earlier and see how the big cloud fabric really addresses it. So John talked about fabric bandwidth, latency, using local switching, using kind of a pass-through modules and maybe traffic going up a couple of layers, which may be creating extra latency. No such thing with big cloud fabric. Really, we have a local switching at the top of rack, and there's a high-performance 10 and 40 gig fabric using modern silicon from Broadcom and modern open networking switches from our white box and bright box partners. John talked about layer 2 versus layer 3 and some of the decisions that you typically have to make. Right? Am I going to do layer 2? It's easy. Maybe I want to do layer 3, but there's some complexity involved in that. With big cloud fabric, that decision is out of the picture, because essentially for us, the fabric is simple and the fabric is automated regardless of whether you're using layer 2 or layer 3. And the fabric provides equal cost multipathing for both of these deployments. Right? So you're really free to choose whatever you want to do. NIC teaming, and you have multiple different NIC teaming options on the VMware side on the virtual switch, whether you're using standard virtual switch or distributed virtual switch. And typically the question comes in, well, what about my network? How is my network going to be configured? I can tell you how many times I've heard of a case where customers configure NIC teaming on the VMware side, but they haven't properly configured the network side, and then they end up having traffic loss and loops and things like that. Again, not an issue with the Cloud Fabric because the network is automated for this. Whatever NIC teaming you have on the VMware side, we would configure the network appropriately, whether you're doing lag or you're doing multi-chassis lag, right, where you're treating 2 leaf switches as a cluster. Right. QoS. Typically QoS, even for smart network admins, even for CCIEs, is a nightmare, right? Having to configure QoS across multiple boxes and going through a couple of different commands, and every time it depends on the platform, really becomes painful. What we have is really a couple of clicks to enable QoS and to give virtual SAN that minimum bandwidth guarantee. And finally, multicast. Right? We talked about the one-click multicast enablement that's irrespective of whether you're doing layer 2 or layer 3. Right? And then the multicast is enabled for entire fabric, and the fabric is ready for vSAN networking, right? Both for the vSAN control plane and the vSAN data plane. Okay. Now, the picture is worth 1,000 words, so I would think that the video is worth 1,000,000 words. So with that, let's dive into a demo. Okay. So in the following demo, we'll see how the vSAN nodes are auto-attached to the fabric, as well as how the transport is configured for vSAN networking. We'll also demonstrate how using test path feature from BigCloud Fabric plugin for vCenter simplifies cluster troubleshooting. Now, let's take a look at our vCenter setup. Here we can see a cluster with 3 nodes. Each has a VM kernel interface and dedicated to vSAN. And the vSAN is enabled on the cluster. And then we can see basic vSAN network health. There are a couple of checks that vSAN provides here, and a few proactive tests that we have. Right? So later on, we'll see how the BigCloud Fabric helps with this. Now, we see here that the integration is enabled, and as soon as it's enabled, we have the interface groups that are configured that are corresponding to the uplinks on the actual vSAN nodes. And later on, we actually have the segment, right? So the transport network for the vSAN is also automated, and you'll see the segment configured over here. The endpoints show up automatically on the fabric, and here are the endpoints that are corresponding to the vSAN. Going to our vSphere Web Client plugin, you'll see some information about the fabric, and you'll see how the vSAN nodes are directly connected to the physical fabric, right? So the things that I talked about earlier in the slides. In terms of test paths, we'll see the view here on the BigCloud Fabric, and we have a couple of tests, actually one test here that's pre-configured for easy repeatability. If we try to do a new test, we'll basically do a test between the 2 VM kernels that are used for the vSAN networking, and see if the controller thinks that this traffic should go through. And here we can see that there is a path for the network. The controller knows that there is a path. Now, we can also do the actual traffic test where we verify on the fabric whether the traffic between the 2 vSAN nodes proceed. And so for that, I was just sending some traffic. And as you can see, the traffic proceeded, and we're able to see, again, a complete hub-by-hub view for the fabric. Okay. So hopefully that was exciting news to you, and you really got to see the capabilities of the VMware VSAN in conjunction with the BigCloud Fabric. Now, one thing that I wanted to mention is the entire BigCloud Fabric support for all of the VMware products. So if you look at here, you will see that for both vSphere, for NSX, for vSAN, and also for vSphere Web Client and the VSLogin side, we provide a lot of capabilities. We have direct integration with each of those products. Right? And most recently for the NSX, for example, we announced the hardware VTAP tech preview at VMworld. We have visibility capabilities that we provide for these products, both for the VM admin and for the network admin. And finally, there are troubleshooting capabilities and really helping you to make troubleshooting faster, helping you reduce the troubleshooting from days or hours to minutes. Right? Just like we reduce the deployment into minutes, we reduce troubleshooting into minutes as well.
Perfect. Thank you, John. Arkady, those were great insights. I had a couple of questions. John, one for you. in regards to
Yeah.
vSAN, what sets vSAN apart from other hyper-converged technologies?
So, I mean, the initial thing is that vSAN is baked into the kernel. It's a part of vSphere. It's native to vSphere. And so that's not just yields performance and low overhead benefits, but also from a management standpoint, if you know how to manage vSphere today, you know how to manage vSAN.
Fantastic. And is 10 gig required? Is it mandatory, or can you still use? Are you okay with 1 gig?
So while 10 gig is not required, really at any scale, you're going to want 10 gig pretty quickly. That said, I mean, as you've noted, you know, the commodity silicon for 10 gig has gotten so incredibly cheap. I don't know why you wouldn't be using 10 gig today. Typically where we see 1 gig has been deployed for edge, robo, little tiny branch offices, but we're looking at moving to 10 gig direct cross connect for that use case. So really I'd say go 10 gig as much as you can.
Yeah, makes sense. I mean, 10 gig, 40 gig is becoming a standard now for all of these new classes of workloads.
Yeah, I'm hearing about some 25 gig maybe next year might become a big thing.
That's right. That's right. That's coming as well. So we're sucking up bandwidth fast, which is great. Arkady, a question for you. How would someone with an existing data center, traditional networking environment, how would they be able to take advantage of Big Cloud Fabric with vSAN and other VMware technologies?
Right, great. That's an excellent question, and one that comes up almost every time when we talk to customers. Everybody has an existing network, existing data center, and even if they love our solution, they certainly cannot wipe everything out at once, and they have to migrate to Big Cloud Fabric over time. Now, what we have is a pod-based architecture where we could create a pod of Big Cloud Fabric as low as even one rack. You could attach that pod using standards-based layer 2, layer 3 technologies to your existing network. And within that pod, you would enable the integration with a vCenter. Now, obviously, your traditional box-by-box network is not automated, and you would have to do some configuration there to enable vSAN across the Big Cloud Fabric and the traditional network. But you'll get to see right away the automation that's happening on the Big Cloud Fabric pod, and that's really an easy way to do things.
And that's fantastic. So if, let's say now you've inserted a Big Cloud Fabric pod, and you may be working with vSphere workloads, and you want to introduce vSAN. What would it take to introduce vSAN?
So I think as soon as you enable the Big Cloud Fabric and you enable the vSphere integration, as we talked about before in a couple of slides, we're really deploying it as easy as 1, 2, 3. Once the vSAN is enabled and you give the appropriate virtual networking site for the vSAN, the Big Cloud Fabric gets provisioned automatically.
So automation is bringing a lot of speed.
Yeah, definitely. And again, you see that quite a bit even with one rack. And really, the big difference comes in when you start deploying it across multiple racks.
Not sure what happened. Let's go back and re-answer that question if you don't mind.
Sure. So, Prashant, could you repeat the question again?
Yeah, absolutely. So now we have Big Cloud Fabric in the data center, which is deployed as a pod connected to traditional networks, legacy networks. Want to introduce vSAN? Additional nodes or existing nodes. What would the implication be from networking perspective? How easy can you add vSAN to an existing Big Cloud Fabric pod?
Yeah, so as we saw with the Big Cloud Fabric, it's really as easy as 1, 2, 3. Once we have the vSphere integration enabled, the networking is taken care of, right? And there's a couple of commands really to enable multicasting QoS. QoS is an optional thing, but typically when you do the network IO control, you want to have the network go hand in hand with that, right? You can't just do the network IO control and then, especially if the network is shared, hope that there's kind of enough bandwidth. So on the Big Cloud Fabric side, very easy, enable the automation and a couple of commands to do the multicast and QoS. And then you typically see the benefits already within one rack. As you deploy the Big Cloud Fabric, you add that little pod to the existing network. And of course, the benefits become more apparent when you have multiple racks, right? So they will support up to 64-leaf switches. So once you deploy that type of network, the automation benefits really hit close to home.
Perfect. question for you, John. Let's see. How big could a vSAN cluster be? How many hosts? Is there a minimum, maximum limit?
So the minimum today is 2 hosts, and a vSAN cluster can span up to 64 hosts in a cluster. So you can go pretty big, and then at that point, you typically break out into other clusters. That said, you can have dozens of clusters managed from a vCenter, so that can go pretty big.
And as you have these clusters that keep growing, that can bring troubleshooting can become tricky. So do you see that having a VM admin, a vSAN admin, having an ability to visualize the network, run flow tracing on the network from the comfort of the vCenter GUI, how beneficial is that to a VM admin?
Yeah, so as I was recently a practicing VM admin not that long ago, and there's one thing to where I joke it's VMware's evil plan is to move the management and visibility plane to be vCenter and our API set. And the thing is when you're trying to troubleshoot and you're having to cross multiple teams and open multiple tools and multiple windows and even multiple disciplines, that gets complicated, and that leads to when you have configuration changes, it takes longer to test, and as time goes on, you're having to your troubleshooting becomes more complicated. And so we really want to avoid that. And the other benefit really to network virtualization, it's not just about the agility, but it's about the consistency of configuration. Because I can't tell you how many times I've come into an environment where you had one host that was flaky because a command got missed, or maybe one port got misconfigured, or a host got replaced and someone forgot to set the LACP policy correctly. That consistency of configuration is really one of the main benefits of automation, because it actually leads to a lot better availability when you have a 100% end-to-end consistently configured host environment as well as networking environment.
So Arkady, is consistency possible? Can a network admin, when they do troubleshooting and look at the flow trace, would it be consistent with what a VM admin would see through the VCF GUI plugin in vCenter?
Yeah, absolutely. Because in the end, when we do test path functionality, for example, throughout the cloud fabric, we log into a controller, either GUI or CLI, we execute this. The controller really has this single visibility for the entire fabric. When we do that for the big cloud fabric plugin for the vSphere web client, really we're talking to that controller again. Right? So that single point of integration for the controller is what gives us that consistency that really you cannot achieve with other solutions.
So consistency is basically through the same single source of truth,
yes,
but displayed in for both network admin in the console that he or she is familiar with, which is the controller, and also the VM admin, the vSAN admin, through the console that they're familiar with, which is vCenter.
Exactly right. Typically, vSAN admins, every time they ask me, yeah, big cloud fabric is great, even though that you have a single pane of glass, even though that you treat the network as one big switch, I really don't want to deal with that. This is my network admin's kind of tool. Right? I just want to stick to my vCenter and troubleshoot over there. Right? And that's really what we help them with.
And it should be noted that there's a lot of hybrid admins today. I mean, I used to be a storage admin, and I joke that's a dying profession and field, is storage admins in many cases have become storage/VMware admins. And in some cases, particularly for the top of rack, maybe not the the far edge perimeter networking or the campus networking, but often top of rack, the VMware admins are actually having to take that on as as teams collapse and we try to move towards more agile, quicker moving teams. So giving the one platform, complete end-to-end visibility. Sometimes this is about just making one poor guy who has to manage everything his job a lot easier.
Yeah, absolutely. So it's sort of like caters to any environment. If you have traditional environment where you have different teams to deal with, you still get consistency. When you have hybrid teams or collapsed teams, cloud teams, where people are working together or the responsibilities are more shared, you can get benefit from that as well. So perfect. All right. If something that we discussed here piqued your interest or would like to know more, just surf over to our website, bigswitch.com, from the comfort of your computer or mobile device, or you can send us an email at info@bigswitch.com. We want to make it very easy for you to get started with Big Switch solutions. There are a number of resources you can download and watch that will give you a tour of our products. In your handouts, you'll see live links that you can access for any of these resources. And VMware also makes many resources available through their website, as well as ability to learn the products through online resources. In order to experience Big Switch, we offer Big Switch Labs. Again, access through the comfort of your PC. We believe there is no better way to learn about a product or a technology other than to actually take it for a test drive. So for no cost to you, online real-time access to SD and Fabric products from Big Switch are available at labs.bigswitch.com, or download the handouts to learn more. Big Switch also offers starter kits. These are starter kits, list price $39K and above, includes switching hardware, software, support, and cables that make it really easy for you to implement your very first SDN-style data center pod, insert virtual SAN in that environment, and get started very, very quickly. If you need more information on that, we have detailed brochures online as well. All of our past webinars, including this one, will be posted online, and you can get those by clicking one of the green buttons on the home page. Also, mark your calendar for Wednesday 21st, our upcoming webinar with Symantec on simplified security orchestration in the data center. And Thursday, October 6th, Big Switch Networks and SDX Central, state of the SDN adoption and data center network monitoring and security. Watch your emails for registration details, or visit our website at bigswitch.com/webinar. Well, that concludes our presentation for today, but if something that we discussed here piqued your interest or would like to know more, just head on over to our website, bigswitch.com. Thank you so much, and have a great rest of your day.